Hello, welcome in. Hi, all. Welcome to our Aligning STEM with New York Standards webinar. As you're coming in, please share with us a little bit about who all is joining us today. We'd love to hear a little bit more about you. If you can, use the chat to tell us about where you're joining us from, your district, your role, maybe your grade level of focus. We'd love to have that information just to contextualize our conversation and be able to really zoom in on the areas that we're looking for today. Thank you so much for being here for our webinar. We're going to explore how to implement STEM with New York's standards and how we can best implement programs in our schools and districts. So as you're coming in, please take advantage of that chat to share with us a little bit about who you are. We'll dive in just a moment. I'm going to give about a minute or so for everyone to come in, get situated, and share some info in the chat. Great to see so many people joining us today from all over the state. Wonderful. Welcome in. Great. I'm seeing a variety of roles, tech integration specialist, PD specialists. Great to see supervisor, special ed, special programs, some superintendents and assistant directors are here. Wonderful to see you. Thank you so much for joining. Great. Some directors of curriculum are here with us as well. Wonderful. Okay, some directors of math and science. Okay, great. Thank you all for joining us. I'm sure we'll have a few people filing in as we get started. If you're just joining us, please share a little bit about your role, your grade level of focus, and what district you're joining in the chat. We'd love to hear a little bit more about who all is with us. As for our side of things, my name is Hope Thompson. I'm a senior manager of curriculum and instruction at NextWave STEM. I'm a former and forever educator. I'm out of the classroom myself. I was an elementary science teacher in Baltimore City Schools and Chicago Public Schools. And since then, I've held roles in instruction and curriculum design for robotics and other computer science technologies from pre-K through 12, which I love to mention because our conversations around technology and computer science don't always include our students in pre-K, but I have seen and implemented programs with preschool students that have been successful and started to introduce some of those concepts that are so important as they go through the different grades towards careers. So I just like to include that because it's a nice reminder that there is room for every student in our conversations around STEM. And as we explore these technologies and integrations into our school days, into our districts, we want to make sure that we are keeping accessibility for all students at the forefront of our efforts and finding a place for all students in STEM and STEM for all students. And I'm joined also by Marcos. Marcos, would you like to introduce yourself?
Hey everyone, thanks for joining us, and I look forward to speaking with you at some point.
Marcos will be in the chat to answer any questions, especially specific to New York, as we are going through our webinar today. I'll also be addressing questions, especially as it pertains to standards, curricula, and implementation. So if you have any questions, please share them in the chat as we go. We'll definitely be keeping an eye to make sure that we're making the most of our time together. So before we dive into NextWave, what we do and how the STEM standards through New York can offer different opportunities and different pathways for STEM programs, I'd love to just get a baseline for what STEM looks like for each of you in your schools or your districts or your classrooms. I saw we have a few classroom teachers with us as well. What is currently your approach to STEM on this estimating scale from 1 to 4? 1 being I'm interested or we're interested in integrating STEM or creating a priority for our district, but we don't yet have a program. 2, Maybe we've started that process of implementing STEM initiatives, standalone projects. Maybe we're doing a STEM or STEAM night, an after-school club at a few of our schools. We've started to think about that process of bringing STEM into the school day. 3, we have a STEM curriculum where you have resources, but we're still building buy-in and fidelity across the district. Maybe we haven't brought it into the school day yet, and our programs are still out of school time, like after-school clubs. Or maybe we have started to roll out a curriculum, but we're just having trouble making sure that all teachers are finding the resources and time to make it happen. And 4, we have a year-round in-school STEM curriculum. We have a program that includes all grade levels. It's been successful, but we're here to learn a little bit more about different options. Wherever you are on that scale, I'd love to know, just as a quick check, if you can drop number 1 through 4 in the chat, and just let us know where you see yourself in your district along the spectrum. Great. I'm seeing a lot of 3s, which is wonderful, some 2s, some confident 4s and 4 pluses. I'd love to see that we have some experts in STEM in the space as well. 2s and 1s, I'm really glad to see joining us too. I hope that today our session can help demystify where we can start with STEM. And if you have somewhere along the 3s and 4s, and you're feeling like you just want to broaden your horizons for your district or have something that's a little bit more consistent, more thorough or complex for your students, then we'll cover some of that as well too. Great. Hopefully by the end of our session today, you'll be ready to sort of move up to the next level, whether it's 1 to 2 or 3 to 4, where you've just gotten a better idea of what NextWave STEM has and how we fit into the STEM space in New York. We have found that 70% of schools that we have surveyed have no STEM curriculum, maybe have some initiatives and are leading with it as a priority as a district, but don't have a solid curriculum just yet. So what NextWave STEM provides is a little bit of support in figuring out where to start so that you aren't pulling from all over, going with one robotics program and trying to find a hydroponics program and trying to find something that's supportive for teachers who have the experience and teachers who are doing STEM for the first time. So we are a BOCES approved vendor. We believe that the world needs young innovators. So we offer hands-on courses in emerging technologies. We have over 35 different curricula designed to give students confidence to express creativity through these emerging technologies. We don't want them just consuming and experiencing technology. We want them to also be designing and using it in ways that allow students to see themselves in these careers, as well as have vehicles for self-expression as they develop these skills. So our goal is to empower teachers of today to prepare students for the future, what we have often called the careers of tomorrow, but increasingly seem like the careers of today as these sort of technological advancements pick up and become very real to our students and the world that they are in. So when we talk about STEM programming, I want to think about what that really means. It can mean so much more than just science, technology, engineering, and math. When we actually put it to practice, what do those STEM programs look like? And we think about STEM through 3 pillars. On one end, we have the process, the engineering and design practices that we want students to be developing. The iterative process of asking questions to solve problems, imagining solutions, planning and building them, whether in the physical or digital spaces, and then engaging in a process of testing and improvement that is ongoing. These are practices that are woven into the practice of science and engineering across disciplines, but we know it's so much bigger than that as well. When they are writing their essays for ELA and they are crafting that draft into a finished product, they're engaging in that same process as well. So many of those STEM process behaviors we practice through STEM programming can give students skills that are making them successful in other areas as well. We also want to expose students to the world of technologies that increasingly they live in and among. So in its own value to show students to technologies like drones, AI, the outcome of this process, these engineering processes, and where those innovations have developed across our society, where those technologies show up. It's not only a way to engage students because it's so much fun, so exciting to see some of these technologies in the classroom. It's also a great way to give students an example of what these processes can build and give them the most innovative practice in developing that final third portion, which are the measurable computer science and technology skills. These are things like computational thinking and algorithmic skills of building sequences and computer science skills that are measured by standards and can be measured as students are completing activities. So we want them to be putting together, whenever we build a STEM program, the process, the technology, and the skills that prepare them for different careers in the world of STEM. When we look at what STEM implementation looks like in different districts, we see two major pathways, depending on what your school or district is able to do to integrate STEM into your programs. And one of those is standalone STEM instruction. If your school or district has the ability to protect time to dedicate to those processes, technologies, and skills. Maybe that's an after-school robotics program. Maybe at the middle and high school level, we're able to bring in more electives in the world of STEM. And in some cases, K through 12, we're able to provide protected STEM time where we focus on those goals only. Through the library and media specialist taking on a 3D printing program, or if we're able to find a time where students are doing STEM in a maker space once a week alongside art and music and PE. Maybe we are able to do that standalone STEM instruction. For other schools and districts, this may mean integrating STEM into core subjects, finding opportunities to use the engineering and design process in other subjects, or technologies integrated into the classroom so students get exposure through those technologies, developing skills in science or ELA. We're going to dive into each of these today to look at examples of what they can look like, especially as they relate to the New York standards, so that you know when you're introducing STEM to your students, you're making the most of that time, whether it's 100% focused on STEM or it's reinforcing ELA science or math skills as well. We're going to start with what standalone STEM instruction can look like. We're going to look at an example or two, but understand that we are more than happy to help meet with you if you see some specificities that you'd like to talk through for your school and district when it comes to a standalone STEM program. We're going to work from our understanding of the New York Computer Science and Digital Fluency Standards. These going from K through 12 focus on these 5 major headlines where students are working on these 5 sections. Impact of computing. So from K through 12 at different levels, students are contending with the concepts of computing and technology through its impacts on society, ethics and the ethical use and development of computing, accessibility for all users, and potential career paths in computing and computer science. Computational thinking, modeling, and simulation is a big portion of that, as well as data analysis and visualization, and algorithms and programming. We're going to look in just a moment at an example of what that looks like at the different levels. For our 9th through 12th graders, that's going to be really specific computer science skills within an algorithm and what sort of commands students are using, what complexity of programs they're building. With our youngest students, our kindergartners, that's going to mean understanding how to break a problem up into smaller steps, even just conceptually. We're working on that computational thinking. Networks and system design, understanding the function and the interaction of hardware and software, as well as a basic understanding of networks and the internet. Cybersecurity, going from risks and safeguards to potential responses. Again, that varies from our K through 12, what the depth and complexity of those specific skills look like. And then digital literacy, digital use and digital citizenship, encouraging our students to be ethical and safe digital citizens in a landscape that is rapidly evolving as new innovations are entering the field. So for each of these, the standards ranging from K through 12 are highly specific within each of these categories. And because our content at NextWave STEM is aligned to the New York State standards, we're more than happy to jump in on a more granular level. We're going to keep sort of a wider lens today because these are so extensive and we are joined by so many educators across the K-12 space. But as an example, I want to show sort of the variety as these same skills deepen from kindergarten all the way up to 12th grade. So in something like impacts of computing, for example, where students are examining how technologies are affecting society and culture, our youngest students are going to start just identifying and discussing how sometimes we use technologies and sometimes we don't. Our second and third graders are going to go into a little bit more of analysis about how those technologies have changed our world. At the upper elementary level, our fourth through sixth graders are describing with a little bit more detail the influence of
I'm
technology,
on a virtual meeting.
as well
Sorry.
as the way our culture influences the development of technologies. Our seventh and eighth graders are comparing and contrasting. So we're deepening that knowledge in Bloom's taxonomy to computing technologies that affect individuals and society. And then our high schoolers are evaluating impact on equity, access, and influence, broadening their scope to include a more global lens. Similarly, those computational thinking skills. At the youngest level, we're just identifying repeating steps in a task. We're thinking conceptually, maybe we're not even introducing the technologies yet. And gradually, we're introducing the concept of conditional thinking, if-then thinking, that can be used to create more complex programs that by the high school level are being used for personal expression or to address a societal issue using conditionals and more complex programs. So depending on which of those 5 categories you want to focus on at any given time, there's a variety of technologies that we can rely on to do that. At NextWave, we focus on these 7 pathways: robotics, drones, AI literacy, 3D design and digital fabrication, innovation, sustainability, and game design. And your goals for your standalone STEM program will include all 5 of those categories, but we would encourage providing a variety of topics to focus in on each of those. For example, something like our robotics or game design is a great way to focus in on the computational thinking and algorithmic planning portions of the standards. Something like cybersecurity or our invention and entrepreneurship provides other opportunities to focus more on impact, safe use, and digital ethical use of digital technologies. So we're going to look at just one example of how focusing on one of these technologies can bring all of those standards to the classroom at different levels. We're going to focus in on robotics, which is a great entry point for any programs that maybe answered 1 or 2 on that question of what you're currently doing with STEM right now. Whether it's looking at introducing a robotics club or doing something during the school day, isolating some of those computer science skills through robotics builds a lot of buy-in for students because they can see in the physical space the result of their work. So with our youngest students, our K through 2, pre-K through 2, we are going to really root that technology conceptual understanding in storytelling. We're going to encourage students to decompose problems and activities into smaller steps, and then introduce a technology that can bring that concept to life. A robot that is simpler like this one, where there's no additional software, also introduces students to the concept of a computing system holding on to data.
All right, that's fine. I won't.
It's going to
Okay.
wait until the student presses the green go button to follow through on the sequence that they have written. So it's holding on to that data for that whole length of the sequence. It also gives students a chance to complete tasks exercise debugging, going back and fixing the errors in their algorithm. And so we're going to focus for this particular pathway on those computational thinking and networks and system development categories. And I've listed just a few of them here. When we're thinking through the K through 2 course, these are the sort of standards that will be touched on here. With our 3rd through 5th graders, students are ready to understand and explore the interaction between software and hardware. So more complex programming that allows them to write a code, connect it to a physical robot that maybe they have even built, and then see the success of their code and engage in the debugging process. So they're getting those engineering and science practice skills of going through that process of debugging and improving, while they're also building the computer science skills that are listed here in this purple box, as specific as comparing two algorithms. So working between groups to say, we're both trying to park our robots in this parking space or to navigate this maze. How are algorithms different? How are they alike? And how do they both complete this task? We're also getting some of that modeling of how computer hardware and software work together. Students are using block-based programming on their devices, like a Chromebook, to complete a program and then uploading it to their robot to try it out. So they're also engaging in a troubleshooting process and an exemplary process of software and hardware interacting. Our middle schoolers, we really want to push towards that purpose-driven activity where we're putting together the connections between the development of these technologies and their impact on our world. So our students are building those same computer science skills, but with a deeper understanding of what the capabilities of those robots may be, responding to and avoiding objects, using sensors, recognizing items or colors in the physical space, and then really working towards problem solving with these robots. How are these skills showing up in the world around us in potential career paths? And how do we see the interplay between our work and the use of automated technologies? Again, just a few of those standards are included here on this blue box, but it's still focusing in on those computing, computational thinking, and the network and systems development. And finally, this pathway, as we think all the way from pre-K through 12, culminates in pushing towards the career and technical aspect of how do we see these skills showing up in careers and how can we prepare, especially our high schoolers, for potential careers in these topics. So using a little bit more of a complex computer, the microbit that has all of these potential attachments like color sensors, conveyor belts, servo motors to simulate on a smaller scale the sort of automation that we see in manufacturing. So for example, students can use the microbit, a color sensor, a conveyor belt, and a sorting wand to have a color sensor sort automation. So as, for example, green and red M&Ms come down the conveyor belt, they have built a system that sorts them in automated format. So again, those computational thinking and network and system development interplay are both represented here. So all the way from pre-K through 12, we can do a deep dive on those two categories of the digital standards through just this one pathway. So when we combine that with additional pathways of 3D printing, of innovation and engineering practice, maybe we find more career path exploration through drones and game design. We can build a comprehensive program that prepares students across all 5 categories and from pre-K through 12. But we know for many schools and districts, standalone STEM instruction is not something that they can promise, especially during the school day. Those minutes that teachers spend in front of students are so precious in so many of our core subjects, and those days are busy. So we know that we're not always able to dedicate 25 minutes every day or an hour a week or whatever we can to standalone STEM. And in those cases, we recommend integrating STEM into core subjects, finding opportunities to bring in the engineering and design process, the technologies that students are seeing developing outside of the world of education, and the computer science skills. This can look a lot of different ways across different subjects. For example, you could use a drone simulator program and the coding of those drone paths to practice the points on a coordinate plane with your 3rd through 5th graders. You could use the building of a simple chatbot on a block-based coding program for students to create a chatbot that behaves like the character in their novel study, or is an opportunity for them to practice things like tone and vocabulary while also getting those computer science skills. So depending on where you see the opportunity in your programs to integrate some of those STEM concepts, it can look a lot of different ways. We're going to focus in as one example on some science standards that can be illustrated through a new technology in hydroponics. So these are some of the life science standards across K through 12 that can benefit from the introduction of a new technology. From kindergarten, understanding what plants and animals need, our students in 2nd, 3rd grade getting a little bit more detail on narrowing down the sunlight and water and nutrients that plants need, but also building the practice skills of planning and conducting investigations. And then as we get to middle school, we're thinking about environmental factors and how they influence the growth of organisms, and then the depth of knowledge that our students develop over high school life science that includes understanding and refining solutions for reducing the impacts of humans on the environment. All of these different standards can benefit from the introduction of the same technology, which is hydroponics, especially if we're thinking on a district and school level. How can we make the most of the introduction of one particular technology when we want to expose students to the outcome of that engineering and design process? When we think through hydroponics at every level, students can get something out of this. From our youngest students who can get new life breathed into their plant life unit as they examine what plants really need. So I want to introduce just the concept of hydroponics as an example, but know that there's a variety of technologies that could be integrated in science, in ELA, and in math. This is just one way that that can look. With our K through 2 students, they're getting a little bit of those parts of a plant, structures, what a plant needs, but having a specific picture of what that can look like, both in the classic, put your seed in a bag with a wet paper towel, and in the more innovative hydroponic system. They get some additional support through appropriate texts. They're getting to cover a lot of those same standards in plant life, while also getting a really controlled environment to grow in, and a little bit of a picture of what the development of technology in the plant world especially can look like. Too often our focus on STEM excludes life sciences, and we spend our time on robotics and drones alone. But this is a great way to explain and explore how innovation exists across all disciplines. Our 3rd through 5th graders get a little bit more practice in the planning and conducting experiments standards. So they're going to examine what plants really need to grow. If I include a little vinegar in what I'm watering them with, a little lemon juice, how does that affect the growth of my plant. And they're getting a lot of data collection opportunities. The hydroponics system not only exposes students to the technologies, but it provides a little bit more of a controlled environment for students and teachers alike to manipulate growth and practice those data collections and scientific observation skills that we want them to be developing in a science classroom. At the middle school level, we are again pushing our students towards problem solving, the impact of technology on our society and culture. So how do these hydroponic technologies help us to solve problems in our world? How do we see them aiding in our development? And where do we see them showing up outside of this classroom? Our middle school students may have a little bit more depth of knowledge as they're pulling a sample from the leaf that they grew to look at the cell structure and isolating chlorophylls. Or maybe they are using their understanding of pH levels to manipulate the growth of their plants. But they're also thinking about how can these hydroponic systems and similar technologies solve the problems that we are thinking about, like food deserts and produce availability. Space travel. One project that students engage in is planning a hydroponic system to sustain 4 astronauts on a year-long space excursion. So pushing towards those problem-solving aspects of the technology too. And for our high school students, we can even further zoom out to see how these technologies fit into the larger landscape of a given industry. Where does hydroponic growth and technology fit into agricultural science? What sort of interdisciplinary tie-ins can we bring to this classroom, wherein students are growing wheatgrass using the hydroponic shelving, then they are harvesting that wheatgrass and blending it into a health drink, and then making a business plan to bring that health drink to market. Again, thinking through the career applications and making sure that students get exposure across disciplines to where technology shows up and how they can be in the driver's seat of that innovation, not just within the engineering and design process, but also in other areas like business, and thinking through what that looks like for a particular product, a particular idea, or a technology. So with that in mind, as just a couple of examples, either your standalone STEM instruction tailored for the standards you want to focus on at any given unit, or if you're thinking more about integrating with other core subjects. We, as an organization, are very dedicated to making sure that that instruction is high quality no matter how you implement. So at NextWave STEM, our courses are standards aligned specifically to New York State, the science and technology standards alike, as well as national standards like the CSTA for computer science, ISTE, and the 21st century skills. So those practices of collaboration, critical thinking, communication, and creativity are woven into all that we do through our NextWave STEM content. We also do provide those ELA and math standards too, because we know not all schools and districts are able to dedicate that time to STEM alone. So if you are looking more at the integrated core subjects approach, we have some standards provided to help as a jumping off point so that you know how to make the most of that time. We are an approved vendor through BOCES, so our content has been approved and confirmed as high quality, hands-on, and engaging for students. Our PD resources are robust to prepare educators, and so our content and our curriculum that we have developed has gone through that process that I'm sure many of you know is quite significant, and speaks to the high quality of our offerings. But I like to be really specific about what those offerings are and what sort of resources you can provide your instructors to, regardless of which pathway you're taking, make sure that they are supported and successful. So that includes a course guide and foundational documents such as a scope and sequence, which goes through lesson by lesson, objective by objective, and delineates the standards alignment for every course. Our teachers' guides are highly supportive. They are what I call just short of scripted. If your educators are leading STEM for the first time, they're going to find these documents to be supportive in a way that gives them the comfort to know that they'll be able to lead their students, but also something to sort of fall back on. If your teacher is exploring coding for the first time with their students, they can follow this content to the letter. If they're an established and experienced veteran of programming and computer science, they can use that as more of a guide. Our lesson plans, our teachers' guides are aligned to the 5E lesson plan. So they are highly supportive for students to have space to explore, to generate their own ideas, questions, and hypotheses before coming back together and making sense and constructing their knowledge alongside the educator. That means they're also highly modular. So if you have 25 minutes and not an hour, you can clearly make a plan for your instruction. We provide a presentation as well, so students are following along with their objectives, especially as the middle and high school courses, their programming may require some modeling by the instructor. Those sort of visual aids are shared through the presentation as well. And we have student worksheets, assessments, and answer keys. One aspect of that BOCES approval is the robust formative and summative assessments. We do have that available as well, so that you can measure the success of your program, of those learning objectives that your students are aiming for through each of these topics. All of this is hosted on our online teaching portal, along with our PDs, resources for teachers to follow, self-paced so that they can address the goals of their course as they go. If they want to return to a topic halfway through the semester, they have that ability to do so. We know that educators have a lot on their plate and their time is precious. It's our job to stay on the cutting edge of these technologies and present that information in a way that is easily digestible to teachers who are the educational experts and also have a full schedule. So those resources are supportive in both the background knowledge that teachers may need to provide support for students, to answer questions, to help with troubleshooting, to monitor the debugging process as students are building those skills too, but also diving into the objectives of the course, the activities that they'll expect. All of that is available on a self-paced library. Additionally, we have a weekly support hour where teachers are welcome to jump on to a virtual meet, ask questions of a member of our team, whether it's about hardware, software, instructional strategy. We want to provide that weekly support as well so that teachers are making the most of their STEM time. And with all of this in mind, I want to give us one more look at the different pathways that NextWave STEM provides. Across the top of your screen, you'll see our 7 pathways: robotics, drones, AI literacy, 3D technology and design, innovation, sustainability, and game design. Each one of the boxes you see here is one of our 15 lesson units, available in both English and Spanish, with all of those resources that I just described. Each of these is specific to a set of skills and technologies. We are more than happy to help you build a program that meets the specific needs of your program. If you are introducing a makerspace, we have we can help customize a menu of options for your students that makes the most of that makerspace. If you want to make sure it's a true STEAM program, and there is art integration, we can help with that as well. There is a suite of courses that are well aligned to those. If you have more of a computer science focus or a CTE focus, we can help bundle different programs to fit those specific needs as well. And many of our courses do include technologies and hardware like robotics and drones that you may already have. You may have a 3D printer. Our 3D printing course is agnostic. It works with any 3D printers that you may already have in your district or your building, as well as a few programs that are equipment free. Maybe your students are only coding on their devices. Maybe they're exploring the cybersecurity concepts that don't necessarily require additional hardware just yet. And I want to definitely emphasize our K through 2 students. Not all of those courses are going to include the technologies, but they're going to start on those foundational skills that safely prepare them to later on explore things like AI tools and drones. So we're happy to help build out programs that meet those expectations for your specific district, school, or classroom. I want to leave you with this link to our curriculum samples. As an educator myself, I know that's the bottom line on and any curriculum is the quality of content there. We stand behind that 100%. We encourage you to check out a curriculum sample that interests you of those pathways that we just explored. I'll stay in for some time and answer any questions. I encourage you to leave them in the chat now. But if you would like to set up time to meet with Marcos or myself to design a program that meets the needs of your school, your district, and is BOCES approved, please reach out. You'll find a link through our website, nextwavestem.com as well. Thank you all for joining us today. I'll stick around. Marcos and I will stick around and answer questions in the chat should you have any. I hope as you are leaving us, you're feeling like you're ready to move up along that scale of 1 to 4 and bring STEM to your students in a way that is long-term sustainable, measurable, and aligned to standards, and most importantly, hands-on, engaging, and exciting for your students. Thank you all.
Hi, Hope. Margot Martin asked if any of our courses are aligned with curriculum from community colleges to allow dual enrollment and opportunities for micro-credentials.
We don't currently have micro-credentialing for our courses, but we are aligned to CTE standards at the 9 through 12 level. So there are a lot of opportunities for students who may be exploring some of these career pathways for the first time. So our robotics and manufacturing, agricultural science, these are aligned to national career cluster frameworks and are a great first stop for students who are thinking about those particular career paths.
Also, is NextWave STEM Ed Law 2D compliant?
I will double check on that specifically. I know that because we are BOCES approved, that does include their privacy and data compliance standards. Students do not access our curriculum directly. Our learning management system is accessed only by educators, and then how the content is shared with students beyond that is done independently. So whether that's analog for our K through 2 students or maybe sharing digital artifacts with students through Google Classroom, that's all up to the teachers. So we don't handle any student data or rostering on our learning management system, which does usually simplify some of those privacy and security requirements. But we are BOCES approved. So if that's under BOCES, then that would comply as well. I'll wait for just another minute or two in case any more questions are coming through the chat. But definitely check out this link through the QR code or our website to see our samples or to schedule some time to really dive in and build a program. I'm more than happy to help ideate around what could be the best fit for your schools. And so please reach out to see how we can build a program that's most exciting for you and for your students. All right, I think we will have gotten to the end of our questions there. So we will be sending out the recording of this session on Monday. Thank you all so much for attending. It's been great to hear a little bit about you and your STEM programs in the chat, and we hope to hear more from you soon. Thank you so much.
Everyone.